right, so an example for confidence interval for one mean is presented here. So this is an example for an AP problem. I'm going to run through the full four-step process for how you would answer this type of question. So activity trackers are electronic devices that people wear to record physical activity. Researchers wanted to estimate the mean number of steps taken on a typical workday for who wear such trackers. A random sample of 61 people working in New York City who wear an activity tracker was selected. The number of steps taken on a typical workday for each person in the sample was recorded. The mean was 9,797 steps, and the standard deviation was 2,313 steps. Before we even go into the problem, I want to point out what it is that we actually have that we're able to use in this problem. We were not given the population mean. We were given the sample mean, which is, X bar, and we are given the sample standard deviation as well, which is usually S sub X. X bar, the sample mean, was given as 9,797. The sample standard deviation was given as 2313, and that was all we were given. Now, construct and interpret a 99% confidence interval for the mean number of steps taken on a typical workday for all people working in New York City who wear an activity tracker. We are now being asked to construct a confidence interval for the population mean in this problem, the population being everybody in New York City who happens to wear an activity tracker. So, four-step process. The first step is usually state. We would like to state what we want to do. Now, what conditions do we have? Well, we see that the sample is random, and the sample size of 61 is greater than 30. Therefore, the appropriate test would be the appropriate procedure would be a T interval. I know that's a bit overkill. We could just say the correct procedure will be a one sample T interval, but I've already written it. So now we have to actually construct the interval. So let's pretend for a moment that we don't have the calculator at our disposal and we want to do this by hand. First, we need to keep in mind what the actual formula is for a confidence interval, for a T interval, that is. So if you recall, X bar plus or minus the critical T times the standard error, which in this case is the sample standard deviation over the square root of n, the sample size. So for this problem, X bar is 9,797, S of X is 2313 over the square root of 61. And we just have to figure out that critical T. Now, if you remember, as I mentioned in class, instead of using a normal table, we would have to use a T table for the confidence level here. So we start at our 99% confidence level, and our sample size is 61, so we want 60 degrees of freedom. Thankfully, that is exactly one of the choices on the degrees of freedom column. So 99 and 60 degrees of freedom gives us a critical T of 2.60. Apologize for the terrible handwriting here. So what we type in our calculator is exactly this equation. My apologies, 2.660, not 2.600. So our upper bound is 10,584.8, and our lower bound is 9,009.24. I know this looks a little bit off. If you like, you can always have that down here and have this in parentheses, but ultimately, mathematically, it doesn't make a difference where you multiply and then multiply by this. Same thing. So upper bound is 10,584.8, and lower bound is 9,009.24. So we are 99% confident that the average number of steps taken by New Yorkers who wear a fitness tracker is between 9,009.24 and 10,584.8. So here you go, there is that interval, there is that statement. The 99% confidence interval is 9,009.24 to 10,584.8. Therefore, we are 99% confident that the mean number of steps taken by people in New York City who wear fitness trackers is between 9,009.24 and 10,584.8 steps. But I guess that's it there, so we're fine. Now, again, let's pretend now that since we're using the calculator, we use the calculator to its full potential. So we're trying to construct a T interval. I guess we already did by hand, but let's do it the fast way now. So as long as you're using one of these and you remember the name of the class you're in and what you're trying to do, you're good. Go to menu, statistics, and we are making a confidence interval using a t-interval. We have stats to work with, statistics, not the raw data. So X bar, the sample mean was 9797. The sample standard deviation was 2313 and was 61. And a key thing to remember is we're using a 99% confidence level, not a 95. So make sure you change that. And there you go. There are some slight differences because of perhaps some rounding error, but it's not that big of a deal. So 9009.16 to 10,584.8. There we are. There's the same interval that we got when we did it by hand. So very good. Now, last but not least, a question that is just here to make sure you're paying attention. Oftentimes, the AP test will throw one of these in just to make sure you're paying attention to the small details. A wellness director at a company in New York City wants to investigate whether or not it is unusual for one person working in the city who wears activity tracker to record approximately 8,500 steps on a typical workday. Is it appropriate to use the interval found in Part A to conduct explained below? At first glance, you would say, well, yes, it's appropriate, and it is weird. He's clearly below the interval. But you have to remember what the interval was for. The interval was for a mean number of steps taken by New Yorkers who wear a fitness tracker. And we used a mean of 61 to calculate that. It is not appropriate to find or to use one individual measurement and compare that to the confidence interval. If instead we used a similar sample, perhaps we found 60 people and found that their mean steps taken was below the interval, then yes, we could start to attribute that to or compare the interval to that. However, that's not what this question is asking. This is asking about one particular individual, one person working in New York City, and it's not really fair to compare one person to an average, right? So the short answer is no, it's not appropriate because it is not appropriate to compare one individual measurement to a confidence interval of means. But if you weren't paying attention, you would just go ahead and say, yes, it's appropriate, and they are below the interval, so it is odd. But yeah, that's the short version of how to go through. I don't know why it's not the short version. This is how you would answer a confidence interval question. We have the 4-step process here. State, we have the plan with the conditions met. The 10% rule is in there as well. I probably should have mentioned that, but of course, 61 New Yorkers is obviously less than 10% of all the New Yorkers who wear fitness trackers, I would hope. So I hope this was helpful.